We are going to learn some very interesting stuff in this new section in 1.6. We're going to learn how to solve multi-step equations. So let's write the word multi right here, multi-step equations, and some very special cases. There's some unusual answers that we're going to get today, and we're going to talk about how we can deal with those. And they're actually pretty cool. They're very nice once you get used to them. You do have to practice and know how to recognize them. But we're going to start with this warm-up right here. So it says, what is a quick way to tell if the following values, so these values right here, are solutions to this equation right here? So we've got one answer that says x equals 1, the other one says x equals -1, and one says x equals 2. Well, if you thought about this, I mean, we could see which one is the answer by actually just going through and solving this and see which one it is. But remember, the whole point of solving an equation is to get the variable on one side by itself, so you can see what number you plug in that would make the equation true. So instead of solving this, what we could do is we could say, hey, look, let's take the 1 and let's put it in right here where there's an x, and let's see if it actually works in the equation. So I'm going to go ahead and do that right here. I'm going to write down -3. We're going to put a 1 right there, so this would be 1 plus 1. And then what we're hoping is that it equals -9. So really quickly you can see that because inside the parentheses this would be 2, that's not going to equal 9. It's actually going to be -6 equals -9. And we know that doesn't work. Okay, so this one is a big fat nope. It doesn't make it true. Let's try this one. Let's plug that one in there. So this would be -3 again. And then wherever there's an x, we're going to put that -1. So this would be -1 plus 1. And you can kind of see that this is not going to work out well because these make a 0. So this side would be 0 and this other side would be -9. That does not work. That's not true. So hopefully this one is the answer. It better be. So we've got -3 from the equation. We're going to put a 2 right here. We're then going to add 1. And we're going to hope that that equals -9. So lo and behold, if we do the -3 right here, we put those together in parentheses, 2 plus 1 is 3. We do get -9 equals -9. Okay, so this one checks out. This one makes the equation true. Okay, so it makes that guy right there, it makes it true. And that's the whole point of solving an equation. You want to keep that in mind as we do the stuff that we're going to encounter today. So remember, when we go through the steps to solve an equation, our goal is to get the variable on one side. We want to isolate it so we get it all by itself. So we want to get it on one side all by itself. And the reason we do that is we want to be able to read off the answer on the other side. Well, when we find a solution to an equation, we've mentioned this several times, what we've done is we found a number that makes the equation true. So just like up above, the one that made it true was the one that the two sides equaled each other. This one made that equation in the warm-up question that made it true. These two made it false. They didn't actually make a true equation, so those were not the answers. Now, there are going to be times where we run into some strange results, even though we do all of our steps correctly. So we practice doing these steps so that when we get to weird situations like we're going to encounter today, we're going to be better equipped to deal with these. So we're going to take a look at some of these problems right here. I've got 4 problems right here. I've got example 1, I've got an A, a B, a C, and a D. And notice how similar these problems are. Notice that they all start with an 8n. We're either adding or subtracting a number. We've got a set of parentheses on the other side, and in every case, take a look at what's in parentheses, a 2n plus 1 on every single one of these. Here we've got a 5 out in front to be distributed through, and here we've got a 4 to be distributed through. So solving these it's gonna be very, very similar on each one. So let's go ahead and take a look right here. So on this side, we're not gonna do any simplification. On this side we are, so I'm going to go ahead and distribute through. So we end up with a 10n, and then we end up with a plus 5. All right, and then we're going to move the smallest one, so I'm going to move the 8n, so I'm going to move that over there. I'm going to move the 5 over to the other side by subtracting 5. So that's going to go away. So we end up with a 2n on this side. We end up with -8 over here. We're going to divide both sides by the 2. We end up with an n on this side and a -4 on this side. And there's our answer. Now there's nothing weird about that at all. We've done problems like this. Okay, so we're in good shape. We followed all the right steps. We got the right answer. That means if we plugged in a -4 here and a -4 there and then went through and did the work, the two sides would equal each other. It would make a true equation. So I'm going to change colors on this one. Let's take a look at this next one. Let's see what happens on this one. So we have, let's see, that 8n plus 5. When we multiply here, let's see, we get 10n, and the other one we get a 5. We're going to move the smallest one again, so I'm going to subtract the 8n. If I'm going to get the n's over here, which again is going to give me a 2n, I'm going to move the 5 to the other side by subtracting 5. And we end up with, well, 5 minus 5 is 0. Now, some people panic at this point and they think, oh, wait a minute, I must have done something wrong. There's nothing left over here. Or some people don't even realize there's a number. They say, well, there's nothing there. 5 minus 5 is 0. 0 is just as good as any other number. We'd have to be careful in a couple of situations, but 0 is perfectly fine on this side. And then let's take a look and see what happens here when we finish this off just like we did before. We end up with an n over here. And some people remember that one of the problems with 0 happens with division. Remember, you can take 0 and chop it up into two pieces. That's totally okay. So 0 on the top is fine. You get an answer. 0 divided by 2 is still 0. That is the solution to that equation. That makes that equation true. If this were flipped upside down, if this were 2 over 0, then we get something that's undefined. We can't divide by 0. Okay, so keep that in mind. We will encounter things like that later in the year. So now let's take a look at this next one right here. So we've got the 8n plus 5, so I'm going to go ahead and write that again. So 8n plus 5. And then on this side, we're going to distribute through. We get an 8n and we get plus 4. Okay? All right, I need to move the variable on the same side, so I can either move an 8n or an 8n. And this is the first time we've come across this where they're exactly the same. So regardless of which one I move, I'm going to end up subtracting 8n from both sides. And here's what's going to happen. That's going to make a 0, and that's going to make a 0. Now, we've never had this before, and notice what we get. That makes a 0, so on this side we only have a 5. That makes a 0, so the only thing we have on this side is a 4. Now, here's what this equation says. This says that the number 5 equals the number 4. Well, there's no way. There's no way that 5 equals 4, so this is not, whoops, let me change this. This is not true. So the way we sum this up, rather than writing a bunch of different descriptions and us all doing it our own way, we're going to write this. There is no solution. There is no solution, and that's what we're going to circle. So we got an answer on this one. It happened to be -4. We got an answer on this one. It happened to be 0. We don't get an answer to this equation. There is nothing that would make this true, because if we kind of follow this back up, see what this is saying. This is saying, first of all, that 5 is exactly the same as 4, which we know is not true. If we look up above and we look right here at this line right here, this says if you take 8n and add 5, you get exactly the same thing as if you took 8n and you added 4. Well, there's no way it works out that way, because if I take the same thing and add something different on each side, they're not going to be equal to each other. So this one right here has no solution to this one. Okay? So this one is no solution. All right, so that's one of those weird cases that we get. All right, let's take a look at this one. So this one has no distributing, so I'm going to go ahead and write down the 8n plus 4. Then over on the other side, I'm going to distribute through, and I get 8n plus 4, because 8 times 2n is 4 times 2n is 8n, and then 4 times 1 is 4. So again, we've got a variable on both sides. We're going to get rid of that. So which one do I move? Do I move the 8n or the 8n? Same thing. So I'm going to subtract 8n from this side and 8n from this side, and the same thing's going to happen that happened on that last example right over here. So we end up with an equals side. The only thing left on this side is a 4, and the only thing left on this side is a 4. Now, let's stop and think about this. The whole point of solving an equation is to find a number that makes the equation true. By solving this one, and we did all the steps correctly, we end up with an equation that says 4 equals 4. This is always, whoops, let me write that, always true. There is nothing that we can do to mess this up. 4 always equals 4. If we trace this back up here and again take a look at this line right here, 8n plus 4 equals 8n plus 4. Well, the two sides are the same. No matter what we plug in there, both of the sides are still going to be exactly the same. So any number that we wanted to plug in there would make this true. So here's what we say. This is always true, so we could pick any number we want. So any number that you can think of would make this true. So I'm going to write any, oops, let me change colors again. Any number works. And again, so that we don't all have our own ways of saying the same thing, this is how we say this. We say that there are infinitely many solutions. You can't even count how many there are. I mean, you could sit there and name off numbers all day, all week, for the rest of your life. Any number that you could think of would work here. So again, the way we say this is we say that there are infinitely many solutions, infinitely many solutions. Okay, that's how you spell infinitely. Hopefully your penmanship's better than mine. So a lot of times we solve an equation, we get an answer just like we normally do. That's the way this one worked out. This one was a little bit weird. Please don't be afraid of zero. Just know how to deal with it. These are both essentially the same problem. We get an answer to these. Now, when we run into something like this, you'll notice what happened. The variable disappeared. When we subtracted 8n from both sides, there was no variable left anymore. And what we were left with was two numbers. And in this case, the two numbers do not equal each other. There's no way they equal each other, so we get no solution. And on this one, the two numbers do equal each other. So there's nothing we can do to screw that up. You can pick any number you want. So the way we say that is there's an infinite number of answers to this. So we say infinitely many solutions. So in this box right here, I've kind of got a summary of what we're talking about here. If we go through the steps and solve an equation and we get the variable on one side and a number on the other side, then we've found one solution to the equation. So write the word solution here. This is what happens most of the time. Whenever you've solved an equation like these first two right here, every time you get one answer, you're all set to go, you're finished, and we feel good about it. Now, there are some times where we run into some unique situations. If we go through the correct steps to solve an equation and the variable goes away, the variable disappears, so write variable right here. So in other words, there's not a variable left anymore, like happened here. There was no variable on this side and no variable on that side, and same thing on this last problem. Okay, if that happens, then there are two cases. We can have infinitely many, so write the word infinitely many, infinitely many solutions. And what that means is that's this case here. We're left with two numbers that equal each other. So if we had 2 equals 2 or 5 equals 5 or something like that, then we'd be all set. So in this example, I did put 4 equals 4. It's just like the one that we had there. This statement is always true. Always true. So what that means is all real numbers, any number that you can think of, all the numbers that you could think of would work when we plug those into that equation. Okay? Now, if we're solving an equation, we do all the correct steps and the variable goes away, and we're left with two numbers that do not equal each other, that's the case where we end up with no solution. So I'm going to put no solution. We're left with two numbers that do not, and I'm going to put a big fat not right there, do not equal each other. So if they do not equal each other, then there's no solution. So I've got another example right here. If we end up solving an equation and there's no variable in it and it says 5 equals 6 or 0 equals 2 or anything weird like that, there's no solution. This statement is never true. Okay, that's never true, so no real numbers will work. There's not a single one that you could think of that would make that equation true. Okay? So that's what we're looking for. Most of the time when we solve an equation, we are going to get an answer, but we do need to be aware of these special cases. If the variable goes away and we're left with two numbers, if they're equal to each other, then infinitely many solutions. If they're not equal to each other, there's no way we can make that true, so there are no solutions. So in example 2, it says, what would be the answer if we solved an equation and we got the following results? Would it be one solution, no solutions, or infinitely many solutions? And you'll notice the way that I abbreviated those. That would be just fine. I would like you to spell that out a couple times just so you're sure you know how to spell the word infinitely. That always trips people up, but we will use some abbreviations as we get going here. So notice on this side, this just says we solved it and we got n equals 4. Well, that would be one solution, and I'm going to put period at the end of SOL. So one solution right there. What if we ended up with 5 equals negative 2? Well, stop and think about that. This says the number 5 equals the number negative true. Well, that's not true. That would never be true, so there is no solution. No solution. So I'm going to circle that one. What if we got 8 equals 8? Well, 8 does equal 8. There's nothing we can do to mess that up. So we're going to write that there are infinitely many solutions. Now, as long as you've written that out a couple of times and you know how to spell it, then we're going to abbreviate this from now on. So let's take a look at the next one. What if we got 0 equals 0? Well, 0 does equal 0. So we're going to write that that would be infinitely many solutions. And put the period at the end there so people know that you're abbreviating that word. So infinitely many solutions. And don't say infinitely many sol. Just say infinitely many solutions. I mean, say the whole word. We're not that lazy. Okay, so let's take a look at this one. If we got x equals 0, remember 0 is as good as any other number. So this is, we got one solution on this particular one. And then let's take a look at the last one. Be careful on this one. 7 equals negative 7. The numbers are the same, but they're different signs. So this one is no solution. Okay, so we'll circle that. Now what I've got down here is some practice problems where we're going to go through and we're just going to solve them like we normally would, and we may get some that have answers, we may get some that have no solution, and we may get some that have infinitely many solutions. So let's see if we can spot the ones that are the tricky ones. So let's go ahead and through and do this. Notice that we've got some simplifying to do. So I'm going to put the two of those together. So we get 3v plus 2v is 5v plus 5. So we've got that side simplified. Over here, when we distribute through, we get a 10 plus 5v. Simplified on both sides, I want to move either the 5v or 5v. If you say that, it just sounds weird. You know you're going to run into something weird. So I'm going to subtract 5v from 5v. I get 5 equals 10. 5 does not equal 10, so the answer on this one is no solution. And some people, once you practice these, they actually like these a little bit better because there's not as much work. I mean, we don't have to write down what the answer is. There's no solution to this one, okay? Let's take a look at the next one right here. So notice that we've got some fractions. There's no simplifying to do, no distributing, no collecting like terms or anything like that. So we need to get the variable on the same side. So we've got a 3/4 n and a 1/4 n. This is the smaller one, so I'm going to subtract 1/4 n from both sides. So if I move the n's over on this side, I want to move that 10 over to the other side. So I'm going to do that by subtracting 10. So I've got that equal sign in the middle. Negative 1 minus 10, that would be negative 11. And then we've got 3/4 minus 1/4 n. So that's going to be 2/4 n, which is going to be a 1/2 n. And just to double check, I'm going to go ahead and pull up the calculator. Remember, we hit alpha F1. I'm going to put in those fractions. Okay, so I'm going to put in a 3, and then on the bottom is a 4, and then I'm going to subtract. See how this is just a heck of a lot easier if you know your fractions, especially simple ones like this. We don't have to type all this stuff in. So minus 1 on the top and 4 on the bottom. This is going to go ahead and simplify everything for us, and it's going to give us 1/2. So we got that one right. So we're in good shape right there. Okay, so we need to get rid of that fraction in front of the variable. So I'm going to multiply by the reciprocal. The reciprocal is 2/1. Now, we could think of everything as a fraction here, but we get kind of lucky right here. What the reciprocal is just the number 2. 2/1 is just the same as 2. So I'm going to multiply both sides by 2. Again, we get some cross cancellation going right here, and we multiply these together and we get negative 22. Okay, so we got no solution on this one right here. We got negative 22 for a solution right here. Let's check this next one right here. We've got a lot of distributing and maybe some collecting like terms and stuff like that. We got to distribute that negative through. So let's see, 2 times u, 2u, 2 times negative 3, negative 6, 3 times u, 3 times negative 4, that's going to be negative 12. And then again, that negative just changes the sign. It makes each one of these the opposite. So that would be negative u, and that's going to be positive 6. And let's see what we've got right here. So this is going to be 2u minus 6. This is going to be, what do we got here? 3u minus 1u, that's going to be 2u. And then we've got a negative 12 plus 6, that's going to be a negative 6. Now you can, if you watch, you can kind of see what's going to happen here. This is 2u minus 6 on this side, and this is 2u minus 6 on this side. The two sides are exactly the same. We're not going to be able to mess up this equation. So let's just double check. If we've got a choice of moving a 2u or a 2u, we're going to subtract 2u. So we end up with negative 6 equals negative 6. Again, that's a true equation. That's always going to be true. So what we write is infinitely many solutions. Now, I don't mind if you abbreviate it again, but I do want you to say this with the full words. So if we write, don't say inf many sol, it's infinitely many solutions. There are infinitely many solutions. That means any number you pick and plug it into the original equation will make it true. Okay, so here's the last one. Let's take a look at this right here. Again, there's no simplifying. Gosh, and these are different. Okay, notice how those are the same and those were the same, the 5v and the 5v and the 2u and the 2u. These are different, so we're going to get an answer to this one, but it may have a decimal in it. So let's check and see. We can either remove the 0.5m or the 0.2m. Let's subtract 0.2m. And let's move this to the other side by subtracting 3. Okay, so those are going to go away. So let's see, we get this is going to be a 0.3m equals, and over here we end up with 5 minus 3, that's going to be a 2. So we're going to divide both sides by 0.3. Okay, so we get m equals, and let's pull up the calculator and see what we get here. It's got a decimal in it, so we're totally okay to do that. So let's see what we've got. Clear this off. We've got a 2 divided by 0.3, and we end up with 6.6 repeated. So that goes on forever. And again, our general rule is that we're going to round to the nearest hundredth. So this is going to be 2 decimal places. So this is either going to be 66 or 67. And the way we tell that is we look right here, 1 past that. If that's a 5 or more, we bump that up to a 7. So this is going to be 6.67. And again, if you wanted to put a little squiggly equal sign to let people know that you approximated that, that would be totally okay. All right, okay, that's the idea. Again, if the variable goes away and the two numbers don't equal each other, it's no solution. If the variable goes away and the two numbers do equal each other, then it's infinitely many solutions. Otherwise, it's just the normal rules for solving multi-step equations.